What exciting science can we expect in 2026? Can dark matter be black holes or even something else? Does light travel forever? And in Q&A Plus, could a rogue planet pass through the solar system? All this and more in this question show. It's time for the question show. Your questions, my answers, as always, wherever you are. Across my channel, if a question pops in your brains, write it down, I'll gather them up, and I will answer them here. All right, let's get into the questions. Bear Cub Daycare. What interesting science is expected in 2026? So the big thing that we're all anticipating is going to be the Vera Rubin Observatory. And of course, this is the big telescope that's in the southern hemisphere that is scanning the entire southern sky every few nights. And it's going to be dumping tons of data out for astronomers to find new asteroids, supernova, Planet 9, aliens entering the solar system, and so on. And, you know, normally with these kinds of like big telescopes doing surveys, you wait that you're going to wait a couple of years for the survey to be complete, and then it's released in this giant data set. And so we've got that with, say, the Gaia mission or with the Euclid mission. But in the case of Vera Rubin, because a lot of the things that it is looking for are sort of breaking news, they're going to be releasing the data instantaneously. And so instead of you waiting, there's going to be places where you can go to watch supernova that it is finding night after night after night, finding the new asteroids and any objects, large objects that are moving, that are being submitted to the Minor Planets Center, and weird stuff that it's finding. And there's going to be all these data pipelines that we're going to be able to watch. So I think that's going to be the biggest thing, is that once Vera Rubin gets operational, just like any week now, we'll be able to watch that and just watch the science pouring out of it. And, you know, it really feels like I know I've been talking about this for years and years. And so I think once it fully gets operational, it's going to feel like James Webb, the same kind of cadence that's coming out of James Webb for a few months, or for like the first year. These new planets were found. This, you know, new gravitational lenses were found. All these asteroids, Planet 9. It goes on, and then, you know, things will settle down as we get more and more accustomed. New interstellar objects. And then things are going to settle down. So that is going to be the story of the year, I think. Not to mention just the really great pictures. And then you've got, say, the Artemis mission, which is going to be sending humans back to the moon. And, you know, although there's going to be a lot of science that's going to be uncovered, I think it's going to really excite people, because this is the farthest that humans will have been sent away from planet Earth in 50 years, like since the Apollo mission. It reminds us that this is a thing that we can do. It's just that, you know, the budgets are very high and the complexity and the risk is very high. And so other things were priorities. And yet, you know, when humanity wants to do something amazing, we can really do great things. So those are the two big ones that I'd say I'm going to be looking for. I think a lot of people are excited about Starship. Hopefully Starship will continue its testing. Maybe we'll see a capture of the upper stage, which would be incredible, right? If we got a full stack launch, bottom stage, upper stage, the whole thing works, that would be mind blowing, because that would show us that we truly have the capability for a fully reusable two-stage rocket. And then I think the big piece of research, or the big controversy that we're getting a lot more information about, is the nature of dark energy. And, you know, we got the initial sort of ideas about this from the DESI survey that, you know, the dark energy is changing over time. And I think we're going to find, you know, we're going to get another round of data probably this year, tell us more information. So we're going to see this story of the Hubble tension, dark energy, get a lot more progress on that. And then apart from that, I mean, I'm trying to think about what other missions are coming up that are going to give us like more scientific information. There aren't any big like sample return missions. New telescopes are going to come online. So yeah, I can't think of anything else that I'm really looking forward to. But you know, always it's always in hindsight. Like I just looked at the list of all of the top stories of 2025, and it's amazing the things that happen. Obviously, you know, 3i, Atlas, other pretty exciting events happened in the course of 2025. And so there's going to be a bunch of random stuff that happened in 2026 that we have no idea what they're going to be. Rob McCachran, could black holes be the cause for gravitational effects we attribute to dark matter? Yeah, theoretically. You know, one of the theories to explain dark matter is that there are black holes. that are, they are definitely qualify. They are dark. They are made of black coal, and that they have gravitational effects. And yet if they're big, say 1,000 times the mass of the sun, then if you had enough of them, they would provide the gravitational effects, and yet they would be really difficult to pin down where they are out there. The other possibility is that you go the small route and you go with primordial black holes, things that are the massive asteroids, and then you just have a lot of them out there. So astronomers have definitely considered this, and they can't rule it out. So it could very well be that black holes can explain dark matter. Or it's a combination, that some amount of dark matter is black holes, some of it is axions, some of it is sterile neutrinos, and maybe some other particle. Ed Skeptic, Y2E. Why can't dark matter be lots of different particles, just like the known universe? Why does it seem they're searching for just one dark matter particle? I'm not sure where you got your information that scientists think it's probably just one dark matter particle. But, when you talk to many astronomers, they anticipate that whatever the dark matter mystery is, whatever the answer turns out to be, it is probably going to be a collection of things, in the same way that the missing mass in the universe, just the regular mass, turned out to be intergalactic dust, intergalactic gas. Like you added up a whole bunch of things, and that filled in the missing composite. It seems most likely that, there's going to be a whole bunch of different particles that account for dark matter. The WIMP, the weakly interactive massive particle, is sort of considered the best candidate particle to explain dark matter. But you have a lot of possible particles that have been proposed that can explain that, like sterile neutrinos or axions and other kinds of particles, supersymmetric particles, and so on. And so it could very well be that we'll turn up axions, but axions will only account for 30% of dark matter. And so you need to come up with the rest. And so it is entirely possible that the dark matter mystery won't just be one particle is found, done, case closed. It's going to be, we got a little bit, then we got a little bit more, and that gives a hint to another little bit. And then it's going to take a while to fill all the pieces in. It's time to shout out our new patrons at the $5 level and above: Mike Stabil, Gary Milliken, Marcel Smits, John P., Joris, Chris Brube, Matthew Hahn, Fionn, Lindsay Holt, and Martin Ewing. Join our community at patreon.com/universe today. New Tech Doe. Does light travel forever? Does it bounce from walls, objects, travels in space forever? Where does it go? So light, as long as nothing interferes with the photons of light, they travel forever. And in fact, we were talking about sort of before the live stream about whether photons decay, and there's no evidence that photons will decay. And so a photon that has been emitted from the cosmic microwave background radiation has been traveling for 13.8 billion years, and it just didn't run into anything, didn't run into any stars, any planets, any dust, anything in between, no people, no eyeballs. Finally, after that enormous time, it has reached for example, if you look up into the sky, you are seeing some photons that came from the cosmic microwave background radiation. Now, you can't see them because your eyes aren't tuned to the microwave wavelength, but they are hitting your face, right? They are hitting your eyes. And those have traveled for 13.8 billion years unimpeded until they reached your eyes. And there's some kind of like really interesting implication. Yes, it bounces off walls or objects. So it doesn't bounce, although it can, but light can hit something, can be absorbed, and then light can be re-emitted. Like light can absolutely bounce off things. We can see reflected light off of stuff, but light can also hit something, get absorbed, and then get re-emitted as a different photon. And sort of an interesting version of this, for example, is, say, inside stars. So you have a star where at the core of the star, it is producing fusion. Because of its temperature and its pressure, it is sort of mashing hydrogen into helium, and this process releases gamma radiation. But the gamma radiation can't go very far. It only can go a few nanometers before it reaches another atom of hydrogen or helium. And so then it gets absorbed by that hydrogen or helium. And then that now that atom has now gained the photon turned into an electron, and then it can emit it again. And then it does it again. And then now you've got the photon goes out and then hits another thing, gets absorbed, gets emitted. And so the photons will do this random walk inside the core of the star until finally they make it all the way out of both the core, out of the radiative zone, and into the convective zone of the star. And it's estimated that light can take, from when the initial fusion reaction happened to when the light finally makes it outside of the star can be tens of thousands, maybe hundreds of thousands of years for that process to happen, for the light that originated inside the star to finally be able to make its way outside of the star. And the other kind of crazy implication is that from the perspective of the photon, because it's moving at the speed of light, it doesn't experience any time. And so like if you go and you punch in Einstein's relativity calculations, you calculate how much time dilation you would experience when you're moving. If you punch in the speed of light, then the amount of time is canceled and you essentially get zero. And so, although a photon has no experience of time from its perspective, it is created and then it is absorbed by whatever it ran into, even though that could be 100 trillion years of time that photon has been traveling before that process happened. So speed of light is weird. Photons are weird. It's all weird. Josh Miller, Fraser, who was one of your favorite people to interview and why? I would say recently was Megan Gianluca, who I was interviewing about the search for atmospheres on the TRAPPIST-1 system. And she had come so prepared for the interview. She had all of the papers that she wanted to talk about in front of her. She knew the names of all of the researchers that she wanted to bring up. And I would ask these questions to set her up, and then she would just roll and just gave me exactly not only the answers that I was looking for, but deeply referenced answers to them with citing all of the researchers and all of their names and just going through in this really logical way. She was a machine, a sight to behold. And it was an absolute sort of pleasure to just be a passenger on that interview. I've never experienced anything like it, So if you watch that interview, you can just watch me just kind of like blown away by what was happening. So I think she was terrific. What a superstar. And then I have people who I really enjoy talking to. And there are so many of them where it's just an easy fit. Like I like talking to Adam Frank. I like talking to David Kipping. I like people who are very comfortable, who have a lot of experience in doing interviews, are very well spoken, and you just enjoy your time with them. And you're like, where did the time go? We can do this all day. Like we could literally just chat about this kind of stuff all day. I just did an interview today with the director of the Columbus Science Center. And it was one of those where we were it becomes less of an interview and more of a conversation, which is, I know, a thing that people find a little unpleasant, I think. They don't like me to talk. They want me to just listen. And like, why are you interrupting him and bring up your own points? And I think it's, because that's how conversations work. As a person says something and you see where they're going and you're just really enthusiastic and you want to jump in. And as an interviewer, it is a thing you are not supposed to do, right? You do not interrupt the person that you're talking to. But as having a conversation with someone, I'm sure that's what your experience is like. It's this give and take. It's back and forth. You're having a really good time. So those for me are very fun when we're having this conversation and we're both sharing ideas and it's really fun. I get that with Jean-Michel Gaultier when we talk. He's sort of very similar to me. We're more just peers chatting with each other about the interesting things that happen in space and less about him interviewing me or me interviewing him. So those for me are very fun, which is different than the times when I feel like I'm being a journalist, right? Like sometimes my job is to take this person who has this knowledge, to pin them down and to extract the knowledge from them for your benefit. And it can be hard work for me. It can be unpleasant for the person who's being interviewed, and it can be sort of difficult for you to listen to. And yet, knowledge is being transferred. You are discovering and learning new things about the universe because of this process. And so it is important work is being done. But other times it can be, hopefully, it can be this very casual, very smooth, very enjoyable conversation that you are just enjoying the ride. And I feel like I've been traumatized by the audience to not do that. And yet I hear interviews where it is this just back and forth, give and take, really interesting conversation with two people who have a lot of things to say and they're really enjoying each other's company. I would like to do more of that. So, you may find that I'm going to interview people, but it's going to feel a lot more like just a conversation. I wish I could do more of that. I always have to sort of like decide, am I here to extract knowledge from this person in an efficient way? Or am I here to have a conversation? And there's no plan. There's no direction that we're going to go. We're just going to chat, and it's going to be, and hopefully, I'm interesting to listen to. They're interesting to listen to. The combination of it is going to be fun to listen to. It's something that you'll enjoy. I hope. So I think I'm going to be brave and do more of that and not feel so sort of, pigeonholed by the audience. Jasper Rust, could a rogue planet pass through the inner solar system, and could it happen in our lifetime? So could a rogue planet pass through the inner solar system? Absolutely. It's estimated that there are more rogue planets in the Milky Way than there are regular planets. And so they're out there. And in fact, there was a paper that we reported on a couple of weeks ago that one explanation for why we have the positions of the planets, the shapes of their orbits, how they migrated outward was caused by a planet moving through the solar system, and not very close. It didn't have to get within, I think it was like 60 AU of the sun, and yet that was, it had a few times the mass of Jupiter, and that was enough to mess up the orbits of the solar system. So will it happen in the future? Well, almost certainly a rogue planet has not passed through the inner solar system. That is a very small target to be able to get to. And the consequences of a rogue planet passing within the inner solar system would be pretty catastrophic and would cause the orbits to change dramatically. And we would see the evidence of that. And so in 4.6 billion years, there's no evidence that a planet has passed through the inner solar system. And so what are the chances that it's going to happen within our lifetime? Very small. What is the chance it's going to happen within the lifetime of the rest of the solar system? Very low. So any of these, like, what if a black hole passes through the solar system? If it did, it would be a nightmare. But it has never happened in the history of the solar system. Otherwise, the orbits of all the planets would be super messed up. And so you can kind of assume that it's not going to happen because it's just a very rare remote thing that's going to happen. Even though there are probably 100 million black holes in the Milky Way, the chances of any of them getting close enough to mess up our solar system is very low. All right, those are all the questions that we had today. Thank everyone who put your questions into the YouTube comments, everybody who joined me for the live show. Our next live show, these are 2 hours long, where I just answer questions live with whoever has them for me. The next one is going to be on Monday, January 12th at 5 p.m. Pacific time. There's already an event here on the channel. You can just go, make sure it notifies you if you want to be able to catch it live and ask your question. All right, I'm going to talk about some anime that blew my mind when I was a kid, but first, I'd like to thank our patrons. Thanks to Abe Kingston, Bear Lake Roofing, Brian Bode, Caradwin, Chuck Hawkins, Commander Baylock, Cy Nielsen, Darkfinger, David Gilton, David Matz, Evan Pro, Greg Feely, James Clark, Jerry Madden, Jim Burt, Jordan Young, Josh Schultz, Marcel Spitz, Michael Purcell, Nordspace, OneStepForAnimals.org, Paul Rohrbach, Ren Kaidu, Richard Williams, Sean Sargent, Stephen Fowler-Munley, Team 49, Telescopes Canada, Wolfgang Klotz, and Zeldaborg Galactic Defender, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So I'm in my mid-50s now, but when I was a kid, when I was sort of like watching animated shows, it was in the late 70s, early 80s. And at that time, we had Looney Tunes, which was like pretty good cartoons, and then just a lot of garbage, a lot of like really badly made stuff designed to sell you breakfast cereal, which we bought a lot of. But and then I think in the early 80s, out came a series of television shows that like just blew my mind. And these were animated shows that came from Japan, and yet they had dubbed them, had sort of redone the theme songs, edited them to make them fit a Western audience, and play them on TV. And so there was 3 that kind of really sort of opened up my mind about an entirely different culture that I had no experience with. So the first one was called G-Force, which was actually kind of like an edited, quite butchered version of a show out of Japan called Gatchaman. And they sort of made it seem very, I guess, good for families, good for children. And it turns out it was much more violent, the original Japanese version, but I wasn't aware of that. And they had a lot of like cool robots that came together and would fight enemies. It was really cool. But the one that really sort of made me excited about this idea of like space operas and science fiction was Star Blazers, which is the adaptation that's the English version of the space battleship Yamato. And it was just amazing. There was like this story was told over multiple episodes, and you would sort of follow it from step to step to step. It was just incredible. And it had, you know, dogfights and with spaceships and this incredible wave motion gun that the ship could shoot. And like, I could not believe what I was watching. And then the last one, which I enjoyed, I didn't like it as much, was Robotech. And they sort of had the Macro Saga, and there was, I forget the next one, The Next Generation. Anyway, there was a bunch of these sort of sequels to that. And still, you know, airplanes turning into robots, fighting each other, character development. It was crazy. So those were my formative anime. And, you know, I think for my entire life, every now and then I'm looking for anime that sort of recaptures a lot of that feeling. And there's been lots of stuff that's been terrific, and I've watched it and I enjoy it. You know, my tastes sort of have shifted over. I'm watching One Piece. I've watched Full Metal Alchemist, Attack on Titan, Delicious in Dungeon. You know, I talk about the various anime that I'm watching here in the channel, but I would love to know, like, what were the sort of the shows that you watched at that sort of very formative age that just, you know, still stick with you, that kind of blew your mind, that, you know, sort of, I'm trying to think of a way to describe this, but essentially had you realize that there was a sort of a wider concept, a wider world out there, different cultures, different ways of telling stories that, hey, it never even occurred to you, never been exposed to it until that moment. Please, I'd love to hear your stories and maybe some new shows that I should be watching. All right, we'll see you next time.